Okay, so let's look at some special right triangles. The 30, 60, 90, what are the sides of that? Here's a quick rule. Opposite the 30 is always half the hypotenuse. So if hypotenuse is 2, what's half of that? 1. And the other side is always 1 times root 3, or that side times root 3. A lot of times in testing situations, sometimes this is called 2x, this is called x, and this is called x root 3. But for our purposes, we're going to use the numbers 1, 1 root 3, and 2. And on the 45, 2 angles are the same, so the 2 sides opposite those angles are also the same. We'll do those as 1, and then this side is 1 root 2. If this was 2, this would be 2. What would this be? Hope you said 2 root 2. Okay, if this is 4 root 2, what's this side? 4. What's this side? 4. All right, if this side's 3, what's this side? 6. What's this side? 3 root 3. Okay. All right, now, based on these triangles, could you give me the 6 trig functions? What's the sine of, notice I'm going to identify theta when I do this. The sine of 30 in this picture. What is it? Opposite over hypotenuse, 1 over 2. What's the cosine of 30? Root 3 over 2. What's the tangent of 30? 30 degrees. Opposite over adjacent, 1 over root 3. Oftentimes we don't like a root 3 in the bottom, so we'll call that root 3 over 3. And the cofunctions, I'm not going to write them, but they're the reciprocals of all of these. So just to save some room here. All right, what if I want the sine of 45? Opposite over hypotenuse, 1 over root 2. Let's call that root 2 over 2. What about the cosine of 45? 1 over root 2. Go figure, huh? 2 over root 2. Whoops, root 2 over 2. Let's stand corrected. Tangent 45. Opposite over adjacent. 1 over 1, or 1. Okay, you can again do the reciprocal functions there. What about this angle here? What if I wanted the sine of 60? Well, opposite the 60 is root 3, so that would be root 3 over 2. What about the cosine of 60? Adjacent over hypotenuse, 1 over 2. What about the tangent of 60? Opposite over adjacent, or root 3 over 1.